In this video, we're going to talk about finding average rate of change. Here are the recorded temperatures at 3 different times on a winter evening. At 4 p.m., the temperature was 25 degrees Fahrenheit. At 6 p.m., the temperature was 17 degrees, and at 10 p.m., the temperature was 8 degrees. How much did the temperature change per hour between 4 p.m. and 6 p.m.? So we're going to first figure out how much the temperature changed altogether. And if we look at this, we see that the temperature change was 8 degrees. The temperature fell 8 degrees, so I'm going to write that as -8. Now, that temperature change happened over the course of 2 hours between 4 p.m. and 6 p.m. So to find the temperature change over 1 hour, I would divide that temperature change by 2. So that tells me that the temperature changed -4 degrees per hour, or the temperature decreased 4 degrees for each hour. Now that may not have been a constant temperature change. It might have decreased 5 degrees the first hour and 3 degrees the second hour to give a total temperature change of 8 degrees. But on average, the temperature decreased 4 degrees per hour. The second question is how much did the temperature change per hour between 6 p.m. and 10 p.m.? So again, what I want to do is figure out how much the temperature changed altogether and divide that by the change in the number of hours. So this one I'm going to write it a little bit differently. My temperature change was the difference between 8 and 17 degrees. And my time change was the difference between 10 and 6. So my temperature change was -9 degrees, and my time change was 4 hours. And if I divide -9 by 4, I get -2.25. So my temperature change was -2.25 degrees per hour. Which time period, 4 p.m. to 6 p.m. or 6 p.m. to 10 p.m., experienced a faster temperature drop? So the faster temperature drop was happening between 4 and 6 because that decreased by more degrees per hour than between 6 and 10. Even though the overall temperature change of decreasing 8 degrees was less than the overall temperature change between 6 and 10, because this was more time than 4 to 6, the temperature change was faster between 4 and 6 because it had a larger drop per hour. So the faster temperature drop was between 4 p.m. and 6 p.m. How much did the temperature change per hour between 4 p.m. and 10 p.m.? So again, we're going to look at the overall temperature drop and divide by the change in hours. So the temperature went from 25 degrees to 8 degrees. So I'm going to do 8 minus 25, and the time change was from 4 p.m. to 10 p.m. So that gives me a total temperature difference of -17 degrees. And that gives me a total time difference of 6 hours. And if I divide those, I'm going to get a decimal, but I can round to -2.8. So the temperature change was -2.8 degrees per hour between 4 p.m. and 10 p.m. So what we are doing here is quantifying how the quantity temperature is changing over time without worrying about smaller changes in between them. So we're not considering in this how the temperature is changing each hour, like we don't know how much it changed from 4 to 5, from 5 to 6, from 6 to 7, but we're finding the average rate of change. So -2.8 is the average rate of change of the temperature between 4 p.m. and 10 p.m. Now, to find the average rate of change, this is a formula that we use, and we used this in these questions up here, where we're subtracting the temperature values, and then we're subtracting the hour values. And if you look at this, this should remind you of the slope formula. And in fact, it is exactly the same as the slope formula. It's just written differently because now we're using function notation instead of x's and y's. But to calculate the average rate of change, you would subtract the y values, or the function values, you would subtract the x values, and you would divide those two values to get the average rate of change.